name is Judith. I am joining you all from Lagos, Nigeria, and we're very excited to have this welcome keynote to kick off the offline element of our hackathon grand finale. We have people getting together to hack in several cities across Africa, and we're especially pleased to have our guest joining us. Marc, welcome. It's a pleasure to have you here. And Marc leads Microsoft's work around computer vision. So very excited to have him. And I will hand right over to you, Marc, if that's okay.
Absolutely. I was trying to share the screen and it tells me that...
I will make that possible right away.
Okay. So anyways, it's actually great to, thank you for the invitation. It's great to be able to participate in this, and oops, let me switch the camera. There we go. I'm really happy. It's actually the first time I give a talk in Africa, even if it's actually virtual. It's too bad I can't be there in person, but I'm really excited about it. I work both at ETH Zurich as a professor and also at Microsoft as I'm leading the lab in Zurich, the mixed reality and AI lab in Zurich, where we work a lot on HoloLens and related services. And in particular, my team is focused on computer vision, which is one of the enabling technologies for a lot of Okay, there's some strange noise.
Apologies for that. Yes, please go.
No worries. Okay, so can you all see? Wait, there we go. Can you see the slides?
Yes, we can.
Okay, perfect. Let me see. So I wanted to tell you a little bit about both a little bit broadly about mixed reality as we see it, and then also in the the backgrounds on the computer vision and some of the research that's going on also towards the future in this space. Maybe first, what is why are so many people excited about AR, VR, about mixed reality? We really see it, and also why are these big companies also investing so heavily in this space? What do they see in it and so on? Well, essentially, we really see it as the third generation, the third wave of personal computing devices. The first generation of personal computing device is a PC. That's a machine to process digital information in front of you. But it's actually a machine that's decoupled from the environment. It doesn't directly kind of perceive or understand what's happening around it. So it's really just about digital information. Second generation is smartphones. It's this type of devices. We carry them with us everywhere. They are much worse computers in many ways. Tiny screen, hard to interact with, to type an email or something like that. But hey, they're always with us. They always, they actually have some awareness of the context. In particular, they have, for example, GPS, and so they know where we are, and therefore they can help us in navigation tasks, for example. As we are looking for the way, they can actually, because they know where we are, they can help us find the way. And if we take the wrong turn somewhere, they can bring us back to the right way. If we look at mixed reality devices, we're now talking about these type of devices here, like the HoloLens, a device that essentially has plenty of sensors and so on. So it needs this to operate to generate the mixed reality experience, but it also thanks to this, has a lot of awareness of the environment around you. So it knows exactly where you are. It knows exactly what you're looking at. At the same time, it will also track the user. So it will have, it also uses technology to be able to understand what the user is doing. Of course, today it's only doing parts of those things, but the potential is really that these devices can much better assist people in doing many tasks because they have much more context of the environment, of the objects that are in front of you, of what the user is exactly doing, where he's looking, etc. All of this is now becoming accessible. And so that combined with being able to go to the cloud and bring in all the relevant digital information means that there's essentially that this device can much, help people achieve some, achieve some task or perform some task in a much richer way. Also in a way, because instead of having, at best an indirect view of augmented reality on a tiny screen, an indirect view of the kind of augmentation and the information you bring in, where the person still has to interpret what is it on the screen and translate that to the real world. The possibility to now have this essentially just place pixels anywhere in front of you through those devices. Okay. So in particular, if we look at HoloLens 2, we have a device that enables really this intuitive, interactive mixed reality experiences and really blends the real world, the physical world, with the digital information that relates to it, and therefore can really help people in all types of areas. People that work with their hands, first-line workers, to be able to work and tackle complicated tasks with all the right relevant information to help them tackle the task and potentially bring in help also. Okay, so what I wanted to dive into now is a little bit, how is this possible, and what are the technologies under the hood, and in particular the computer vision technology. So if we look at HoloLens, there's essentially a number of sensors here. The first one is a video camera. You can take, this is essentially a camera that's meant for communication, for being able to record the experience or for communicating with others, letting others see what you are seeing, so that if you want to bring in a remote expert, he can kind of more or less see through your eyes, through this here, which is very close to your eye position, and essentially that way be able to help you in achieving the task. So this is really a communication camera, and this is the only one that actually gets exposed to the applications that run on the device. But then under the hood, there's many more sensors built in. In particular, we have these 4 cameras here. So there's one here and another one here. This forms a stereo pair, like our eyes, essentially two different sensors looking at the world in front of us, combined with an additional cameras that look on the side, the one here on the right and on the left. They provide more peripheral vision. Together, they allow to both, by having 2 views, you actually immediately get a sense of depth in those 2 cameras, and you know how far things are in front of you. So you can reconstruct a map in front of you. You can track this map. And the peripheral views allow us to, even if we, for a head-mounted device, if we quickly turn our head, to still be able to track the map that we've been building for tracking. Okay, you could ask, why do we need to track? Well, oh, and by the way, the tracking actually combines cameras that see the motion essentially in the environment, together with inertial measurement, with an inertial measurement unit, so accelerometer gyroscope. And in a sense, this is very similar to what humans use for estimating their motion. We use our eyes, but combined actually with our inner ear system. And it's the 2 together that allow us to perceive our motion. And it's exactly the same type of basic principles that are used in HoloLens to estimate the motion. And in all the other inside-out tracking devices, also VR devices and so on nowadays. Okay, so why do you actually really need to know how you're moving through the world? Well, if I want to place a virtual hologram in front of me, attached rigidly to my device, then it's easy. I just display it on the screen and that's it. But if I want to actually place an object in the world and it should rigidly look like it's rigidly attached to the world, then I need to know exactly how my head is moving, how the device, that's then on my head, how the device is moving in the world, so that the relative pose between where my system is and my displays are and my eyes are, and where the object should appear, that I exactly know that relationship. That requires me to track the motion. Okay, it actually, with a see-through device, contrary to a phone device, where you can actually tolerate a small delay between the images that show up here and the images in the world. With a device like HoloLens, which actually is optical see-through, and so I see the world with 0 milliseconds delay, I have to be able to bring these overlaid images with a very minimal delay, on the display. And so HoloLens is doing all kinds of tricks to be able to hide the latency, the intrinsic latency of doing the computations of the motion computation, combined with the time that you need to actually render images. And I'll come to that in a second. In addition, we also have a depth sensor built in, which you see here. It essentially measures for every pixel, it can measure not only an intensity value. Think of this system here as a spotlight. These are two spotlights, one wide field of view and one narrow field of view, but more focused with more energy in the narrow beam. So those two, one to track as we'll see, to track the hands, one to actually reconstruct the environment. And then here a camera, a 3D camera, or a special camera that allows us to measure depth for every pixel. Okay, it's essentially projecting light that is modulated at a certain frequency, and then the pixels are also modulated at a certain frequency. And if they're in sync, you get a lot of it. Your pixels are bright, and if it's out of sync, then your pixels are darker, and it directly relates depth with intensity in those images. And if you take a few images, you can actually compute that. Okay. What do we do with this? On the one hand, we reconstruct the environment. Why do we need to reconstruct the environment? Because with AR, the environment is already in front of us. So, we already see the environment. Why do we need a reconstruction? Well, we need it if we want real elements virtual elements to interact properly with real elements. In particular, if I place an object, I would like it to just, sit on existing surfaces. If I walk behind the surface, then I want the holograms that are now hidden, I want them to be occluded properly, etc. So that's why we need to actually build a 3D model, even if we don't need to show the 3D model to the people, to the user. As a byproduct of that, we can actually, as you walk around the whole, a larger space, you can actually build up a 3D map of the whole environment in the background. It's a byproduct of using HoloLens. And you can do more semantic analysis on that and recognize walls, surfaces, etc. And it will build a floor plan out of this, essentially as a byproduct of using the device in that space. Second thing is, the camera with the more wide field of view mode is used, but with less energy, so that it only goes up to about 1 meter out, is used for tracking the hands of the user. Not like in HoloLens 1, with just clicking, detecting clicking signals, but actually fully articulated hand tracking. Every finger, every angle of every finger is measured all the time, actually at 45 times per second with very low latency. It's a combination of using, as you see in the illustration up here, machine learning models to detect the hands and detect the key points on the hands to initialize an approximate pose, and then geometric optimization algorithms that will adjust precisely to the depth measurements the pose of the hands. And so then what you see below here is some applications of this hand tracking in action manipulating holograms. Then we also have cameras, as you can see down here, 2 cameras that look at the eyes. And there's also a number of infrared LEDs that are mounted around the rim here. And those will reflect on the eyes. This is in the infrared domain, you don't see those. But they reflect on the eye and they allow us to precisely measure where the eye is. And then within that, we can actually find where the iris is. And so knowing where the eye is located and where on the eye the iris is located, we can calculate precisely in which direction the user is looking. And that can be used for human-computer interaction purposes. Like, for example, here, as you read the text, it can automatically scroll along because it knows where you are in reading the text. But actually, more importantly, it's actually also used for iris recognition as a biometric authentication for the device. In addition, and maybe the most important thing to actually make HoloLens work properly is that this allows for display calibration. In particular, what's essential when we want to render an object in front of you is to know how far apart your eyes are, because that directly means how different the 2 images are that we show, the image from the left eye and from the right eye, how far apart those have to be rendered, okay? Some people will have their eyes 6 centimeters apart, other people will have their eyes 7 centimeters apart. Now that's 15 to 20% difference. That would mean if we don't take that into account, people would see objects 15 to 20% too big or too small when this is miscalibrated. And so it would deteriorate the experience. In particular, would be inconsistent with when you move your head, how you then perceive the change of depth, so-called structure from motion versus structure from stereo. So that would be somehow inconsistent and would create discomfort over time. Okay? In addition to that, for perception, there's also microphones, in particular 2 microphones near the mouth, to combine to 3 microphones that get environment sounds, allowing to really be sure when the user is speaking, when someone else is speaking, and also to still have this work in very high, in very noisy environments. Okay, so everything I showed you is a ton of computer vision, which if you were trying to run this on a normal CPU and GPU on a PC, each one of those would, fully saturate your PC to do this in real time. So to be able to do that on HoloLens on a device that, as a total device, the whole device here consumes less than 10 watts of power. It has to do that because it has to be passively cooled. You don't want a fan on your head. So essentially, Microsoft had to build an ASIC here, so-called HPU, to do all of this processing in real time at very, very low power. The whole ASIC consumes less than a watt and does all of this real-time processing for computer vision. All this middle part is pretty much computer vision except for the audio. This is the DNN, inference engine, eye tracking, head tracking, computing the raw depth signals to an actual depth image, surface reconstruction, etc. And then there's this block here, the depth-based LSR. This is a graphics warp engine, which allows us to hide the latency. In particular, the way that it works is like the motion to photon latency. As I move my head, the cameras are going to see that things have changed. So this gets, the images from the cameras gets processed through the head tracking block here. It estimates the change in motion, combines it, fuses that with the IMU measurements. It tells the graphics engine to render from that new position. But that would already be way too long. So actually, the way it works is that we predict forward and we say, okay, a few tenths of milliseconds from now, when the GPU will be ready rendering the image, for what position should it have rendered it so that it's in the right position, at that point in time. So we predict forward, let's say, 30 or 50 milliseconds forward, where we think we will be with our heads if we extrapolate from where we are now. And based on our previous motion. Okay, so we predict forward, we render there, and then by the time we are ready to show the image, the GPU is done, and we're ready to show the images. We look at the latest IMU signals, inertial measurement units, which are much faster to read and to process, and we might realize that we have to slightly update our position from which we render. We send that to the depth-based LSR, that information. So just before the image actually gets sent to the screen, there's a small image warp that gets applied to do a last minute or last millisecond correction. This brings the total motion to photon latency, perceptible kind of motion to photon latency, to below 10 milliseconds, which is critical in giving on HoloLens the impression that holograms are fully rigidly attached to the world. Okay. So beyond the processing in the front, where all the raw sensor data is processed, in the back, you get access through APIs to all of these results. You can get access to the camera, and this is where the applications run. Okay, so it's also important in terms of separating, in terms of privacy, all of these sensors that are active all the time, and then letting applications actually just get access to high-level signals. Okay. Now, what can you do with a device like this? Well, for example, things like planning and design, people together looking at a virtual, not yet constructed site or so, or going on site during construction and looking at things. Many of those things might be very complex, renderings, not like this one, but it could be something with millions of polygons. Then we can actually also use the cloud to do the rendering. So the device can ask to the cloud, please render an image from this viewpoint, and then send it back to me when you're ready. You get it to the device. Thanks to the HPU that can hide latency, we can actually, we've been able to build out an effective service, which is called Azure Remote Rendering for HoloLens. Okay, so this way you can actually also look at things that are not on device limited to about 100,000 polygons, but potentially go to millions or 100 million or even a billion polygons in a service. So beyond that, once the site is constructed and you walk around, one of the key things is to be able to, the use cases is on site, you might have a lot of sensors, IoT sensors that measure all kinds of data that's available about those machines that run here, that gives the status, that says, like the history and so on of all the sense data and so on. Normally, it is only accessible for analytics in the back end office and so on, in the back office and all. But the goal with HoloLens, you can actually walk around the site, and now with mixed reality, you can bring up all this information. You can make it available to people in the field on the factory floor. They can look around and access all this data, not only on a small display that just shows the current state, but like fully have access to all of the information processing tools and analytics and so on in a way that's suited to whatever task they have to fulfill. Then some of the key applications that are available today out of the box and people use, one is remote assistance. It's really having a person in the field that might be a generic technician combined, teamed up with a remote expert that can then see what the person is seeing. And the person, by seeing what the person is seeing, thanks to the depth camera, thanks to the stabilization, the 3D kind of tracking in the world, the remote expert can annotate the world in front of the person in the field with arrows and so on that are attached to the world, not just on an image, but actually attached to the world as holograms. And so give clear, not to be misunderstood instructions to the person in the field. And so together, this team of two people, the remote expert and the local technician, together become a very powerful team in solving all types of problems without requiring travel from the remote expert, for example. So this opens up a whole new world of efficiencies as well. Another application is actually for not an emergency task with something very complicated, but more a standard task that every new person in the factory has to learn. For example, let's say you're Volkswagen and you build a new type of car, and now all your technicians in all of the different garages all over the world have to learn how to fix the new model of cars. Then you can program it as a guide, as a step-by-step tutorial on how to do a certain instruction. And through mixed reality, this becomes something much simpler, much more intuitive, where people can build up the confidence of doing those tasks, very efficiently in a way that that doesn't require kind of the expert to, like a teacher to explain like step by step and spend a lot of time on every single new person that has to be trained up. So there are also a lot of efficiencies possible. Okay, if we look beyond that, at some of the things we're doing in the lab, one of them is actually learning to just, instead of having to program these tutorials, to actually just do demonstrations and record demonstrations. As an example, here just a simple, how to make coffee kind of step-by-step instructions. But essentially, instead of having to spend a lot of time building a tutorial with a lot of digital assets and so on, can we just record this as an expert is just showing by demonstrating once and record it? Actually, beyond that, what we really want to do is also build in intelligence, being able to recognize and understand the actions that people are doing. What you see here is purely from an RGB video stream. We're able to see what the hand is doing, to find where the hand is, find which object is being manipulated, and also, as you see here, close, for example, understand which action is being carried out. The goal of this is to make HoloLens or devices like this, mixed reality device, more intelligent, and essentially be able to understand and follow along what the user is doing. There again, with the goal of better assisting the person, or being able to help the person if they forgot a step to remind them about this and so on. If you want to do some of this yourself, and in particular in the context of a hackathon, for example, and so on, and try out some of these new capabilities, with HoloLens 2, and actually the same with HoloLens 1, we actually have a research mode, and so you can switch the device into a developer mode and then research mode. There's a number of more information on this website. This can give you access to all of the raw sensor data. As you see here, the depth map, and then some of the images, but there's a lot more available. This you can get in combination with all of the, information here from, also the high-level APIs, like for example, what you see here is a reconstruction thanks to the sensors from HoloLens, the depth sensor and the color image sensors, together with the APIs that tell you where the head is. The cyan arrow is, and the cyan dot is where you are looking, and the hands, when the hands are in view, the hands show up also. And here on the right, you see a little bit of a recording of combination of color camera with the depth map in terms of recording the hands also. So a lot of things become possible with this device in a sense of doing egocentric computer vision things. Okay, so I think I'm kind of running out of time, so I have to kind of kind of quickly skip through this here, but one of the key services we work on a lot in Zurich is Azure Spatial Anchors. This is a way to let people share experiences in mixed reality and also persist information. So let me skip this, but here it's about essentially a HoloLens, like a phone. You can place an anchor, place a hologram with your phone, and then here the person wears a HoloLens, and then the hologram also shows up in the right place at the same location with a HoloLens. The goal is to be able to share experiences and have joint experiences, also persist over time. Here, this is after a week retrieving the same hologram. This was used actually in Minecraft Earth to enable these experiences there. This is me playing in Zurich. But as I said, it was really about enabling these type of kind of contextual data access, accessing information that's spatially localized that makes sense. Here's another example of this in a construction site, being able to see what you are supposed to construct while you are constructing it, so people can see if they're actually following the plan or if there's a mistake, or maybe also that maybe something in the plan doesn't make sense. It's better if you can pre-visualize it in context. Under the hood, what's going on? Well, think of devices walking around the space. Just to operate, as you said, they have to build maps to be able to track off. If we move that to the cloud, then others can access the same maps. If you have multiple devices, they can each move their maps to the cloud. After a while, you start getting overlap, and you can essentially puzzle back a broader map back together. That's really essentially what we are aiming for in Azure Spatial Anchors, to be able to have this understanding, spatial understanding of the world. These are about 100 HoloLens sequences, all merged together automatically from a few minutes walking around here and there in the Microsoft Studio A in Redmond. So the dots you see are points that were used for tracking while the person was walking around the space. All of this in the background. I skipped this, but this is essentially research we are doing. As you can see here, you can see it's a bedroom from the point cloud. You can recognize some of the elements here. We're looking at, but we need this map to be able to relocalize, to know where, if I come with a device, to be able to get back to the experience I had before and so on. There's, for some applications, there's a need to share these representations potentially in the cloud. So the question is, can we go to other representations, like these soup of lines here that you cannot recognize, but it actually represents the same space and allow us to still relocalize ourselves with respect to that space. In particular, this is actually showing that with a standard method, if you upload an image with features, you can actually get these type of reconstructions of the images purely from the, not having uploaded the images, just having uploaded some visual features that allow us to relocalize. But if you launch inversion attacks on this, you can still see a lot of the content in the images that's potentially a concern for privacy. With our new methods, we can actually, as you see on the right here, you don't see any faces or any kind of personal information here because we use a privacy-preserving method. So let me skip this video. And to finish, essentially, we also, all the techniques we use for enabling mixed reality devices to share information and to have a common spatial understanding, we can also expand this to robots, because robots essentially use exactly the same techniques. These techniques are called simultaneous, localization, and mapping. So while you relocalize yourself, you actually also are helping building the map. And so this simultaneous localization and mapping is called SLAM in robotics. And so we can leverage the same techniques, and therefore, if both have cameras, we can actually do joint experiences between also robots and people, not only people and people, and enable scenarios like this one where we have a robot and a phone. The phone is localized. It's all using Azure Spatial Anchors. The person can indicate where to go. This gets transmitted to the robot. The robot sends back its plan to the device and can be visualized on the screen. And at the same time, there's a digital twin of all of this that plays out, in a digital representation. Let me actually then finish with this short video here, showing some of that as kind of the last video show. Robots are increasingly a part of our daily lives, at home and in the workplace. Mixed reality allows us to blend information from the digital world into the physical. At Microsoft, we have been working to bridge the gap between robots and humans by leveraging mixed realities. Azure Spatial Anchors is a mixed reality cloud service that uses computer vision to localize devices to distinct places in the environment, persistently over time. These spatial anchors can be shared between Android, iOS, and HoloLens devices to anchor holographic and digital content to the real world, or to give all agents a common coordinate system. We are excited to announce that we have extended Azure Spatial Anchors to enable robots to localize the same anchors, allowing them to share a coordinate system and spatial data with mixed reality devices and each other. This allows robots to have greater autonomy by accessing contextual information from other devices and from mixed reality cloud services.
In addition, co-localization with mixed reality offers many new possibilities for human-robot interaction by giving people insights into the robot's state and intentions, and enabling natural modes of interaction through hand tracking and gaze tracking. The robot needs to be equipped with a calibrated camera and its own pose estimation system in order to create and clear the Azure spatial anchors. For example, this can be done through a visual SLAM algorithm or by having a camera mounted on a robot navigating with LiDAR.
This is a special research SDK release targeting Ubuntu 18.04 and 20.04. We provide a ROS1 wrapper for easy integration into your robotics projects. Please follow the link here for more information about the SDK and how to get started using Azure Spatial Anchors in your robot.
Okay, so to conclude, mixed reality headsets have the potential to bring much more, to have much more context, user and task context. So by observing the user actions, understanding the environment, at the same time accessing relevant digital information, and then make all of this easy for the user through natural user interfaces. Interesting open questions and opportunities are the combination of edge and cloud computing, and figure out how to relate that. Big open questions also are with respect to telepresence, having, projecting remote presence of the users, avatars, etc. We're tracking a lot of things of the user. How can we leverage that, and so on? Allowing users to remotely access places, for example, through robotics. The synergies between HMDs, robotics, ambient sensing, like cameras attached to the environment, and then other sensors like IoT sensors, Internet of Things sensors attached to the environment. And again, in all of this, it's really, really important to think about privacy, because obviously those are super powerful devices, but even more than phones, they are recording and registering lots of things through the sensors, and finding the right trade-off between privacy and utility, and finding, by also looking at the algorithms and finding the right kind of balance between those, and develop algorithms that allow you to get the right utility without sacrificing privacy, are all super important topics. And so I think I run quite over time, but that's it. I hope you enjoyed it, and I hope it was interesting. And happy to take questions if there's any time for that.
Oh, thank you so much, Marc. That was absolutely fascinating. I mean, speaking for myself, I could let you go on and on. So thank you for sharing that. Everyone, Marc has kindly offered to take some questions. You can go ahead and type those in the chat if you'd like to ask a question. And while we wait for those to come in, Marc, if you don't mind, maybe I'll go ahead and ask the first one. And mine is kind of like a really broad question. I'm wondering, if you project 5 years into the future or 10 years into the future, what do you see happening with, this mixed reality technology, and what are you looking forward to?
So I think for now, we're, it's still very much about the potential. As I mentioned, in terms of applications, the things like remote assistance, these guide scenarios, that's kind of ready as technology and can be deployed today. If we look at really this walking around the factory and seeing all the layers of digital information, we're kind of getting there, but we're not quite there. So that will take a little bit of time and so on. So these kind of larger spaces, fully kind of digital and digital twins and reality kind of blended together, or being able to blend that together and find the right filters that allow us to see things that are of interest to us, not overloaded. All of this is going to evolve, and I think a lot of interesting work will happen in that space, and all of this vision will become much more reality in the coming years. I think the seamless collaboration between not replacing people with robots, but actually having teams of people and robots effectively working together, have people do what they're good at, and robots do kind of the boring jobs or the kind of moving stuff around that's not very interesting. Find the right balance. I see a lot of that happening in the next 10 years, a lot of evolution there, a lot of, hopefully we can really find interesting and good balances there. What I also see is that currently, if walking around with this device here, Okay, I'm not gonna walk like with this in the street, right? This is perfectly fine in a factory context or when I have to do a very concrete task. I think what we'll see in the next 10 years is this device is shrinking, you know, becoming, you know, hopefully more something like this device here, right? And something that is socially acceptable, where also, again, the aspect of privacy will be, you know, fundamentally important to tackle in the right way, find the right balance there. You know, in the next 10 years, we'll start getting to the point where we are today with phones here, where, you know, they're just part of our daily life. We use them and they're kind of a given, and we kind of forgot how we were doing things before. I expect that 10 years from now, we'll start being at that place where we kind of, many of us are having these devices, you know, using these devices, you know, a lot of the time. So that's what I'm looking forward to.
Thank you very much for that. We've had one question come in, and this is from Fabrice. And he says, so the main problem in Africa with this technology is access to it. And he's wondering what the strategy might be around the HoloLens or mixed reality in general, the African strategy might be. Do you have any insights on that?
I don't have too many insights on that. I think you know, I think it's something that you know, at Microsoft, for example, I know that this is something that we're thinking a lot about how to do that. There's indeed many kind of challenges. I think part of it is actually in you know, part of kind of starting addressing that, I think, is actually also build up development teams in Africa. And so, as probably many of you know, we've opened part of our team is now based in Lagos. It's a growing team, and so it's actually fantastic for us. It's also very cool, like working for Microsoft. It's very cool to have people in the same time zone because most of our other colleagues are in Redmond. So I think that's actually part of it, is actually really investing in building up a local ecosystem, in building up actual, you know, having real work on the ground. And I think that will lead the way in a lot of enabling all of those things. Obviously, there's some HoloLenses in the office in Africa and so on. I agree, getting this to you know, actually getting broader deployments, getting people to use this type of tech. I think there's certainly many scenarios that are particularly relevant in Africa for this type of technology. You know, I'm not an expert in how to tackle get the devices there, but I'm very hopeful, having seen how, you know, with cell phones, which initially were envisioned to be something that would, you know, mostly deploy in countries in Europe, in some countries in Asia, in North America, and so on. And then actually, no, it went the other way around. Often it was rolled out much quicker in Africa because there wasn't the kind of older technologies that people were already bought into. And so it kind of bootstrapped beyond immediately. And I think there's a chance for that also to happen in some ways. But I think we still have, of course, a long way to go. By the way, everywhere, this type of technology is still very niche in all over the world. But I'm pretty hopeful.
Thank you so much. Okay, so we have another question. We have another couple, actually. And someone from Pollefeys in Nigeria is asking, what needs to change in the XR world for hardware to become cheaper and more accessible?
I think this will come as, you know, as this goes from more commercial to more, you know, consumer devices. If I look at, I have here from the competition, you know, from Oculus, this is already a much more accessible device in terms of price point, right? These are a few $100s as opposed to a few $1,000s. So I think as we go to more consumer, I think this will become much more affordable, and so I think mostly that's where it's going to be. For the rest, it will remain also. HoloLens is not something that's meant to be used by you know, like for you know, for directly by consumers. So maybe in some experiences in a museum or something like that, but it's really a commercial device, an industry-oriented device. So I think that technology, as long as it's in that category, it will remain expensive and hard to get by. I think once we can move to consumer, and you know, most of the large players in the field are clearly, you know, as soon as we can build a compelling product that can be cheap, you know, that's cheap enough for people to afford it, that you know, that is appealing. The problem for now is, you know, a device like HoloLens with these capabilities is actually, it's a fight between the capabilities, making it just work and possible, and shrinking it, and it's opposite forces, and making it cheap. Like all of this is fighting each other. And so, but as we step by step, you know, move along, you know, as the volumes increase, then you can start, you know, further shrinking, get economy of scale, get investments. There's some things we know how to shrink it, but you know, it takes a lot of investments, and so those will only be taken step by step. So I think we'll get there, but it's still a long road ahead to. I think VR is a lot simpler, and of course AR can be accessible through phones, but that's only a very indirect AR experience, of course. But so I think something is accessible, but the full thing is going to take a while to get in consumer hands, I think, and be compelling.
Of course, thank you. So we have another question, and this is from a participant who's an architect, and he is interested in your thoughts on use cases for mixed reality in architecture and how it can be best deployed.
I think there's plenty. I think both in the planning phase, you know, instead of building a cardboard model to kind of show people that is a static representation that doesn't show necessarily alternative options, that cannot show different layers as easily and so on. With mixed reality, with augmented reality, it becomes pretty straightforward to have all of this accessible interactively. Multiple people can see the same thing. You can point at things. You get the advantage of a physical model, but you know, like in terms of using our spatial understanding, being able to move around it, things like this, which if you just show even a 3D model on a screen, you don't have quite the same. You cannot leverage the people's proprioception, the sense of motion, to help in spatial understanding. With mixed reality, you can really do that. You can essentially, as you move around, you kind of naturally kind of see the other side, and you understand much better the 3D, you know, objects. Both with mixed reality, you can both look at the whole concept, and you can zoom in and go inside and see live scale, and go inside the room and see these things. So super powerful, I think, at the level of the concept and before you build it, and kind of to get, for non-experts, the architect knows how to interpret 3D data and how to think in 3D. But then the customers often don't, and then there's that problem of communication. Here, this can really help with kind of completely taking away that boundary, because people know how to look at a 3D house if it's built, or if they can see it visually in front of them and understand it. And so for communicating the designs and also looking at alternatives and maybe making people really understand what you mean, I think it's super powerful. Then, you know, and as I showed a little bit in the examples also, then while you construct, there's a lot of opportunities, especially for more complex projects, you know, to kind of follow along and look at the digital plan, what was planned and what's actually being built, and also follow along for maybe spotting like things that you didn't fully realize, but once you kind of see them overlaid on the real world, like in the setting, also go look at the design in context, you know, like in the actual space, have a virtual object of the right size and see it in context and see if, oh, you know, that window that I was planning there, it's actually looking at like, you know, a wall. So maybe I should put the window somewhere else. These kind of concepts that you can see when you're in situ. And then, of course, along the way, also for, you know, I don't know how you call it, but like architects that are more, you know, planning the inside of the house and like furniture and these, like remodeling parts of the house and so on. Also, they're very powerful of being able to pre-visualize what it will, you know, what it would be, what the end result will be. Because there again, people don't always fully understand, you know, what is actually meant. So I think, and also in terms of trying out furniture virtually, there's lots of opportunities to do these things. IKEA, for example, has these small apps, right, for doing that. But I think this will be generalized, and it's much more powerful if you have it in a direct augmented reality as opposed to an indirect one.
Thank you. So we have another question, and I think this is probably a critical one for most people hacking on the continent. They want to know if they want to start building for the HoloLens or doing mixed reality, how do they get started? And let me add that, you know, for quite a number of them, they want to get started, but they don't have access to a HoloLens. So what would you recommend?
So I think there's simulators. Depending also what you do, there's some data sets and some possibilities. There's also I think you can essentially fully build applications purely on the kind of on a simulated HoloLens essentially, and try out already a lot of things and so on. So I think that's certainly an option. I think beyond that, it's clear that you know, I don't know exactly how, but it would. I think it would be really important to figure out a way to get you guys some devices somehow, because in the end, that's really when you really kind of understand like how it works and so on. But yeah. You know, for the rest, I don't think I can.
Okay, fair enough. Thank you so much. Just kind of like following on from that, are there kind of like different platforms that you would ask people to start exploring? I mean, obviously we can see it makes sense to start looking to Azure spatial anchors, but what else would you tell people to dive into?
You know, I think that's actually the one where, you know, my passion really is, and I think that's one. The nice thing about that is you don't need access. Any phone will actually allow you to play with Azure Spatial Anchor. So that's really one I would recommend, because any phone that has either ARKit or AR Core, so you know, will give you, like, you can essentially program Azure Spatial Anchors. You know, you can start exploring Azure Spatial Anchors. You know, certainly in the things that we work on and so on, that's actually the first thing I would really like suggest to play with and to explore. I think there are lots of things that can be tried out there, that are pretty exciting. So and I would love to hear, you know, if some of you have feedback in trying it out, because that's actually really the service that most of my team here in Zurich is actually working on. So I'd love to hear feedback there. Yeah.
Brilliant. Thank you so much. Okay, so let me check with our audience. Are there any last questions? I'm sorry, Marc, I know we've taken up so much of your time, but does anybody have any last questions before we let Marc go? No? Okay, well, I cannot thank you enough for sharing your knowledge and expertise with our participants. And, you know, I know a lot of people aren't able to, you know, log on right now to join, but we will be sharing the video on YouTube so the rest of the participants can watch. Is there any way in which you would like to kind of like follow up with what we're doing? And if there are any more questions, can we send them across to you?
Yes, I mean, I think if there's questions, please send them to me. Also, you can always reach out to through Group.
Yes.
Yeah, absolutely.
All right. Well,
okay.
Thank you so much. It's been a pleasure. Thank you very much.
Thank you for inviting me. It's been my pleasure. Bye-bye.
Bye-bye. All right. Thank you, everybody, for joining us this afternoon. This is the end of the welcome keynote. We wish you all the best with the rest of your hacking. Oh, I see one more question is trying to come in. Well, if you type the question, then we'll try and make sure that we get a response for you and share that later on. But otherwise, thank you all for joining this afternoon. I hope the hacking is going well. We can't wait to see what you all create. Good luck, everyone. Happy hacking.
Thank you, Judith. Cheers.
You're welcome.
All right. Thank you so much, Judith.
Thank you. Oh, Egypt,
Joining
Rwanda in the house. How are you all doing?
Good.
Oh,
Say
look
hi.
at everybody. Hello.
Hi. Yeah. Thank you so much,
Thank
Judith.
you all.
Yeah.
All
right. So we'll go back. Thank you.
Thank you. Good luck, everyone.
They are done.
I'm close.
And they are saying good luck.
Oh, Ghana. Hello, Ghana. Yes, we've just finished, but we will put the recording up on YouTube. So once that's available, we'll let you know. Good luck with your hacking.
The guys in Nigeria are feeling left out, so they want you. They want some time on the screen as well.
Oh, let's see them. Come on. Hello, Port Harcourt.
Okay, let's Ghana. Before type there. Say Ghana here.
Hi. Hello. Hello, Port Harcourt. Fantastic to see you here. Wonderful.
Everybody say hi. Say hi.
Hi. All right. Thank you, Port Harcourt. Hello, Ghana. Are we going to have a hello from you? Any chance we'll get to see the hackers? Can you put your video on?
One hello from Ghana. So who do you want to speak?
So who is on? There. The cameras are there.
Hello.
Hello. Hi, Bless.
Hello.
Where are you?
Yes.
Ghana.
Oh, hello, Ghana.
Yeah.
How is the hacking going?
Very well.
Fantastic. Fantastic. We can't wait to see what you build. We're so excited.
Sure.
Wonderful. All right. Well, thank you, everybody. It's been fantastic to have you on. We wish you all the very best. And we look forward to Sunday and all the fantastic announcements after we see what you've built. Good luck and bye-bye from all of us here.
Bye-bye.
Okay.
Bye.
Bye-bye.
Bye.
Bye.
Bye.